Hello students, myself is prachalita, lecturer in physics, Kottureshwar College, Kottur. Here in my today's session, I am discussing about the phenomena of optical activity. So here, the phenomena of optical activity is nothing but it is a phenomena of rotating the plane of polarization about the direction of polarization of light by a certain crystals or a substances, we can say, that we are now calling it as an optical activity. Okay, see, for example, a quartz crystal or a sugar solution or a tourmaline. So like this, a different substances are rotating the plane of polarization when a polarized light is incidenting, when it is passed through the an optically active substances. These optically active substances are differentiated again into two types based on the at what direction those substances are rotating the polarized light. So what are those two types are nothing but one is dextrorotatory substances and another one is a leorotatory substances. These dextrorotatory substances are nothing but the substances which rotate the plane of polarization towards a right side. That is nothing but if the substance is rotating the plane of polarization in a clockwise direction, so such type of substances we are calling it as a dextrorotatory substances. And in the other hand, we have the leorotatory substances where few substances, those substances which are rotating the plane of polarization in an anti-clockwise direction, that is towards a left-handed side, we can say. So those type of substances we are calling it as a leorotatory substances. Based on this optical activity, there is one more term to define which is very important, that is a specific rotation of a particular substances. This specific rotation is unique for a given optically active substances. That is, that specific rotation is nothing but it is nothing but when a plane of polarized light is passed through an optically active crystal, then there will be a rotation of that particular polarization. That is, there will be a rotation of a plane of polarization through a certain angle theta. Okay, if you pass a plane polarized light through any optically active solution, then what happens? There will be a rotation of that particular plane of polarization through an angle theta, and that angle theta is proportional to a length of the liquid column. You can see here that angle theta is proportional to the concentration of the solution, and it is directly proportional to the length of the liquid column through which it is passing. That is, the angle which is rotated by the optically active solution, that is theta, is proportional to concentration of the optical solution, concentration of the optically active solution. Then it is proportional to a length of the optically active solution, the length of the liquid column what we have considered. And that we can say that theta is proportional to, it is directly proportional to L into C, and that proportionality symbol is replaced by the constant, that is what we are calling it as a specific rotation, that is specific rotation of a given optically active solution, So how we can define the specific rotation? How we can define the specific rotation for a given particular optically active solution is nothing but it can be defined as the rotation produced by a 1 meter length of the solution, a rotation produced by 1 meter length of the solution of concentration 1 kg per meter cube, 1 kg per meter cube. This we are calling it as a specific rotation. See, once again, what is the specific rotation? The specific rotation of a solution is defined as the solution that the rotation produced by 1 meter length of the solution having a concentration of 1 kg per meter cube. This is what a specific rotation. And how we can measure the specific rotation of a given particular substances? How we can measure a particular specific rotation of a given solutions? How much? There is an optical instrument, what we are calling it as a polarimeter, and by using that polarimeter we can measure the specific rotation of a given solution. So The polarimeter is an optical device which is used to measure the specific rotation, you can say. So what is it polarimeter? How it is going to work? What is the mechanism inside the polarimeter which is taking place in order to measure the specific rotation? Here, this polarimeter, mainly we are terming it as a with a name that is a Lorentz half-sheet polarimeter, in which the name itself indicates this polarimeter contains a special device in it, that is what we are calling it as a half-sheet device. Okay, let's go through the polarimeter, how it is going to work and its construction and all. Okay, here, and this polarimeter consists of a source and which is illuminating an unpolarized light, and when that unpolarized light is made to pass through the polarizer N1, then after passing through the polarizer N1, the light which is emerging out of the polarizer N1 will be a plane polarizer, we can say. So there, which is that again the plane polarized light is made to pass through the a half shaded device H, and which is made up of, this is very important, this half shaded device is made up of a half part of it is made up of a glass plate, and a half part of it made up of a quartz which is an optically active. Okay, then if you made to pass the polarized light through that half shaded device, then what happens? There will be splitting up of that plane polarized into two parts with its optic axis perpendicular to each other, and a half part will be transmitted through the glass plate and half part will be transmitted through the quartz. Then what happens? If the light is which is emerging out of the half shaded device is made to pass through the sugar solution which contained in the Lorentz tube, it is having its own particular length, it's having a length. Okay, and its own concentration. That optically active solution which is present inside the Lorentz tube is having its own length and its concentration. Then what happens? According to the definition of specific rotation, the optically active solution having a particular length and having the concentration is going to rotate the plane of polarization about the direction of polarization. Then the light which is coming out of the sugar solution, means an optically active solution, then it is made to pass through the rotating analyzer through which we can clearly say at what angle that light is polarized, If you go on rotating the analyzer N2, then you can observe a twice of the light extension throughout one complete rotation. With one complete rotation, you can observe a single shade in that field of view. So then you can say that the light is polarized at that particular angle theta. So at that particular angle theta, the sugar solution or any optically active solution is having its particular concentration and it is having a particular length, is rotated that plane of polarization at that particular angle theta. You can conclude that, and that angle of rotation, that is the value of that theta, is noted, and then these trials are repeated for the different concentration of the an optically active solution, and the different angle of rotation is theta is noted. Then after taking the data regarding different values of theta for the different concentration and different length at constant length, if you plot a graph of angle of rotation versus the concentration of that particular solution, then the slope what we are getting is going to give the value of specific rotation of that particular optically active solution. See, what type of optically active solution we can choose in order to conduct this experiment for a different concentration is the molecules which are a chiral molecule. The molecules which are chiral molecule can exhibit an optically active phenomena. Those types of substances, those types of chemicals only can exhibit an optical active phenomena. Okay, so this is what. See here, if you consider the sugar solution in our laboratory, here also the sugar solution, which is nothing but a chiral molecule and which is going to give its own optical rotations when the plane polarized light is passed through it, and that specific rotation of that sugar solution we can find out by taking the by attaining the different concentration and by taking the readings of that particular theta in the polarimeter, and the slope what we are going to get, that is s is equal to, you can substitute by substituting all those values theoretically and graphically, we can find out what is the specific rotation of that particular sugar solution for the different concentration. Okay, this is all about the optical active phenomenon, optical activity phenomenon under the specific rotation, and also regarding a polarimeter. Okay, I hope all of you can understand. Thank you.